you there. How's it going? Algebra class. Where's everybody else? Hey, how's it, brother? My name is Mr. Dalsey. No. Alright, so check this out. Apparently, we've got some Chinese delegates coming in, right? They're all coming into our school and they're going to be visiting us from China. I think they just arrived this morning. So they're coming straight over to our school. And yesterday, they said, Mr. Dalday, could you play some Hawaiian music for them? I haven't played the ukulele in a long time. So I'm just kind of getting into the mode, you know, into the mood of things. So anyway, that's kind of my deal. I'm gonna call your class and say, where is everybody? Because you guys got to show up for class. Like, that's the bottom line. If you don't show up for class, you guys are shooting yourselves in the foot. So.
Am I allowed in here?
Yeah, come on in.
Okay.
So, just to give you a heads up, I actually have someone show up.
Oh, yeah.
While I was talking about you need to show up. Move the jacket, you guys can, or move the bag, you can pull up that chair over there. How's it going, Brandy? So, what I was telling them is I was saying that there's going to be these Chinese delegates that come in today. And
Excuse me?
they asked me to play the ukulele for them. Hold on one second, my phone's ringing. Hello? Hey. Yeah. 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 I understand. Okay. I'm actually in class right now, but you can RSVP for the meeting for me. I'll be there. Okay, love you. Of course I can. Love you back. Alright. So sharing is caring. My wife just called and says she's not going to be able to make it to church because guess who else got sick? Because of me. My wife. Anyway, I'm a little better now.
Sick.
Yeah, I know. I know, it's terrible. I got sick from my kids. So my kids got me sick and then I got my wife sick. So what I was saying is I got to go and play for some Chinese delegates. I'm kind of stalling right now just in case I want more people to come because you guys got to show up for class. Of course, the people who are watching this right now are like, I'm here in class. What are you talking about? And I was like, yeah, but this is for the people watching the archive. Yeah, I'm talking to you. Anyway, and they want me to play Hawaiian music for them. And I'm like, okay. So, anyway, I got my ukulele. You can call me Uncle Kimo for the rest of the day. And let's get this party started. So, what I'm going to do is I'm going to do this in my best, but probably slightly offensive pidgin English I can.
Oh,
as best as I can. And the reason being is because I'm from Mililani. And Mililani, we don't speak towny English, but we speak towny English. I hate to say it. I mean, I'm from Waianae. I actually used to teach out in Nanakuli and Waianae, and it was like, oh, Mr. what? And I'd be like, well, you know, I mean, don't call me Mr. and everything. So, I mean, I don't have, so, anyway, let's get this party started. I actually want you to try out these things. Today we're covering part 2, and what we're talking about is graphing things, because one way to represent a function, right, is in an equation, and we've decided that anything that has an x squared, right, even if it's like a 3x squared or a 1/3 x squared, as long as it has an x squared in there, that equation is called a what? Come on, say it. Starts with a Q. How many words do you know start? It's called a quadratic equation. Can you guys hear me all right? All right. Anyway, yes, it's called a quadratic equation. It has to have an x squared in it. In fact, a lot of times I saw you guys' homework, and some of you folks thought that like some of them They're like, oh, that's not quadratic because it didn't have an x term in it, or it didn't have like a plus term in it, or whatever. But as long as it has an x squared term in it, it's a quadratic. Cool? So that's one way to define a quadratic equation, or parabola. Another way is to graph it. I like graphing it. Graphing it's very nice, because that way I can see exactly what it looks like. Hey, look, it looks like that. Cool? So that's what we're going to work on. So here's what I want you to do. In your mind, graph x squared plus 3. What does that mean? What should I do there? And by the way, just because, you know what? Because you guys haven't said much, and only Bernice has been talking to me, and Brandy, of course, because she's right inside the back of my ear, say good morning. That way I know that you're listening to me.
Good afternoon.
All right, that's wrong. Good morning. There we go, Bernice. Bernice is the only one so far who can hear me. All right, there we go. Good morning from Jonathan and Adriana. Come on, you guys. Say good morning to me. Come on. It's a good morning, isn't it? It's Friday morning. You get a 3-day weekend. Be excited about it.
I just learned about that last night.
I know. It's so
like,
exciting.
Yes.
I'm like, ah! Come on.
I don't go to school on Mondays anyway.
Thank God it's Friday. What is that?
Pretty sure there's a swear word in one of those F's.
Thank God
Pretty
it's
sure one of them is.
friggity fraggity Friday. All right. Anyway, so Tatiana can't hear me. Kingston can't hear me. I'm just going to assume the worst since Ted, you can't hear me because I'm going to assume that you can't because you're not saying good morning. You can even say I hate mornings. I just want a response from you. Okay. All right. Anyway, here's my question for you. X squared plus 3. How do you think that affects the graph? This is just a guess. I'm not going to grade you on it. What do you think? What should I do to graph that? Do you know? If you don't know, say IDK. You can actually.
I don't know.
You can actually say I don't know. Jonathan says IDK. Give me your best guess. You're even allowed to guess privately if you want.
I don't have an option, sadly.
You can just whisper it to me. Alright. So Jonathan is the only one who doesn't know. Randy doesn't know. Come on, you guys, start talking to me. Alright, there we go. Adriana says, I don't know. Okay, I'll tell you what. Okay, fine. Jonathan says, will it move up 3 spaces? Okay, alright. Since that's the only guess, why don't we go with that? Why don't we just say, alright, I'm going to graph this, but instead, I'm going to graph it up 3 spaces. Would that be good? Alright, so let's try number 2. What is x squared minus 1? If we're going according to Jonathan's logic, which I'm not saying is right or wrong, but if we're going according to Jonathan's logic, what would this do? By the way, x squared is this graph. This regular graph that's already on there, that's x squared. That is the regular quadratic equation. It's actually the regular parabola, the most standard parabola you can get. We've graphed this, right? Right? We've done this. So x squared minus 1, what do you think that will do? I know, Jonathan, and that's what I'm asking you to do. I'm asking you to guess this. This warm-up is called a guessing game. Guess. What do you think is gonna happen? Go down 1 space. All right, cool. So it will be, oh, that's terrible. Sorry. It will go down like this. Just a little bit lower. I want you guys to pull out your worksheets, by the way, and start writing these notes down. If you don't have your worksheet, then you should print it up before class. And if you don't have that, just start taking notes. All right? What do you think this is going to do? Negative x squared. Okay, so x squared is going to be going like this, and it's going to be opening upwards, right? If I negatate that sucker, what's going to happen to it? What do you think?
You what?
If I make it negative in front of that, if I put a negative 1 in front of that. I know negatate is not a word. I'm not an English major. I'm a math major. It gets flipped. It gets flipped. Okay. All right. Fine. It will go upside down. So like this. It bows down. Okay. All right. Do you guys agree with what I drew? This is page 1 of. It's the next section.
Yeah. There's a whole next section.
Yeah, you didn't print out the next section.
Did I not?
All right, so just start taking notes. All right, good. All right, what do you think 2x squared is going to do? Start guessing it. Can you show the number 2 real quick? Yeah, sure, of course. Number 2, Jonathan, we're going to credit him with that. So if he's wrong, everyone blame Jonathan. Is x squared minus 1 really just takes the parabola and moves it down 1. That's what Jonathan says. That's what Jonathan Hubbard says. I'm just letting you guys know. Okay. All right. Now, what do you think the 2x squared is going to do? I'm just curious to know whether or not you guys would even be willing to guess. And by the way, all right, it makes the parabola wider. Let's go with that. I like that. It's a good guess. Sound good? And what do you mean? Isn't that supposed to be the b? What are you talking about? Oh, are you talking about it's the y-intercept? The y-intercept is going to go down? Is that what you're talking about, Kingston? Yeah, okay, let's try that. Let's see if the y-intercept is -1. I'm wondering if that's going to be the case. All right, ready? What do you think 1/2 x squared is going to do? If Ted was saying that 2x squared is going to make it wider, what do you think 1/2 is going to do?
Sorry, what?
It's going to make it thinner. So a parabola kind of like this. It doesn't move it up. It doesn't move it down. It just kind of makes it skinnier. You know, it's like the parabola on the skim fast plan, right? The skim fast. I kept saying skim fast. The skim fast plan. Blah 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 blah. All right, ready? Yeah, I know. My brain is slow. Okay, and then the slim. That's it. The slim fast plan. All right. What do you think the -x squared plus 2 is going to do? I'm just curious to know whether you guys understand. I mean, not understand. I just want you to guess. -x squared plus 2, what do you think that's going to do? What is the negative going to do? I'm just going to ask that off the bat. All right. Kimilani is saying it's going to move it up 2. Okay. It's going to be flipped and up 2. So it's almost like I'm going to go move the whole thing up 2, but I'm going to flip it over as well. Kind of like that. You guys agree? Is that what your guess is? I mean, I'm not even guiding you in a certain place. I'm just kind of asking, and you guys are telling me. I'm doing what you guys are telling me. We cool? I think these are good guesses. These are great guesses. And see, the thing is, remember how I told you, I hate it when I have teachers pull equations out of their butt and then throw it up on the board and say, memorize it for the rest of your life. Yeah, I usually say pocket, but I mean, you guys are 9th graders now. I can say butt. Right, back in 8th grade, I didn't say the word butt. But I mean, you're just saying.
Terrible.
Yeah, I know. Anyway, I hate it when teachers pull equations out of their butt and just throw it up there and say, memorize this, right? So my goal is just to play. I like playing with things. I like playing like, I wonder what would happen if we messed with this. I wonder what would happen if we changed this. And that's what we're doing. We're kind of throwing out a guess out there, and then we're going to see whether or not we were correct. That's what the game we're going to play today is. That's the game you guys should play in math. Because, you know what, to be honest with you, that's one of the best ways to approach math. You know why? Because when you start challenging yourself and when you start like learning this stuff and like, the world is a puzzle, and let me see if I can solve it and figure it out, that's going to make you a better mathematician. You're going to be a better math person. You'll understand what you're talking about a lot better. You know what I mean? If you're the one who made up all the rules for it, then you're going to understand the rules. Do you guys agree? Yes. No. Yes. Okay, good. All right. So let's try this. Okay? Cool. Let's do it. Let's graph f of x equals x squared. Okay? So that means what I'm going to do is, and Jonathan was asking me, how did you fill out this table so quickly? Well, what I'm doing is I'm going to take my x values, which are these guys right here, all of these guys, I'm going to plug them into x squared. And then I want to figure out what f of x is equal to if I have -2 substituted for x. So what is -2 squared? Now, Ted, I'm going to have to ask you if you can possibly put you on mute. Just because I feel like I hear you typing on my head. All right. 4. Good. Perfect. -2 squared is 4. Everyone agree?
Yeah.
All right. -1 squared, what is that? 1. There we go. 0 squared? 0. +1 squared? 1. And +2 squared? 4. Awesome. Awesome. Good. Not 2. 4. Good. So if we were to graph this, this would be at -2, I would go up 4. So it would be 1, 2, 3, 4. That dot right there. At -1, I would go up 1, so that would be right there. At 0, I would stay at 0. At +1, because we're just reading off this guy right here. At +1, I would go up 1, and then if I go to the right 2, I'm going to go up 4. Does everyone know how to graph those kinds of numbers? The coordinate system? You guys know how to do that, right? All right. Feel free to say no. It's fine. Put in a private message if you don't want other people to know. All right. Then, okay. Ramana said no, and I'm not upset. I'm gonna take a second to explain it to her just to make sure that we're good. So the way I got this first dot, the one on the left side. I'm so sorry, Ramana. It's a him. Yeah, I'm sorry. I actually had a student named Rayana, and sorry, I'm sorry. How embarrassing. Okay, anyway, the way I got this first coordinate, the one on the very top left one, you see this one right here, is I'm looking at this point right here, and this says -2, 4. There's like a comma in between. And the way I can graph that is I say, okay, this tells me to go backwards 2, or to the left 2, because I always talk about going horizontally first, so it's either going right or going to the left. So the -2 tells me go to the left 2. The 4 tells me to go up or down. So the first number is left or right. If it's positive, you're going right. If it's negative, you go left. And the second number tells you go up and down. If it's positive, you go up, and if it's negative, you go. When I do this, by the way, this means answer. It goes down. Exactly. Good, good, good. So that's how I got each of these points. Ramana, are we cool with this and how I graph this? Okay, good. Awesome. Thank you. Thank you, my man. Yeah, man. You're such a cool dude, man. Anyway, I'm going to graph this parabola, and it looks like that. And we're not surprised because we've seen this parabola all the time. Yeah? We good? Okay. Do you know what the domain and the range is? Have you guys ever heard of that?
Yeah.
Why do you do ugh?
Ugh. Because it's an ugh.
What's wrong with domain and range?
Because it's just an ugh.
Do you understand what it is?
Yeah, but it's an ugh.
What is it then? If it's so ugh, what is it?
It's one of those things that you know, but you can't.
You can't explain?
Words.
Really? No, it's not one of those things that you know that you can't put into words. Let me have a chance to tell you. Okay, ready? All right. Since I didn't get to be your Algebra 1A teacher, I'm going to tell you my chicken katsu story. Because I love chicken katsu story. Have you heard my chicken katsu story?
I can't say that I have.
You have not heard my chicken katsu story?
No.
No, that's too bad. It's an amazing story. Okay, ready? You've learned about these guys, f of x.
Yeah.
What are they? Those are called functions, right? Functions. All right. Now here's my question for you. This is for everyone in the class. Have you ever eaten katsu? Yes or no?
Well, yeah, obviously. It's a silly question.
No, I mean it's not obviously. Apparently Ted
Did Ted
hasn't.
just say no?
Well, I mean Ted always does opposite of whatever. But what I mean,
Touche.
what if you're new to Hawaii and like you just
I
moved
lived in
here?
Florida until I was 10 and I still had katsu.
Up in Florida?
Yeah.
Okay, all
It
right,
was
fine.
crappy, but it was
All
still
right.
katsu.
So my question is, have you eaten katsu? Okay. Now I love Kingston. All right. So Kingston is actually that's awesome. So what if they had katsu in Texas? Oh, that changes up my example all the way. Oh, all right, fine. I'm going to still use it anyway. All right. So let's say that you've eaten katsu. Everyone has told me that you've eaten katsu. Apparently, you guys are super like Hawaiian and eating katsu all the time, except for Ted, and that's fine. Ted, I'm not going to discriminate. But what I'm saying here is, what is katsu? Have you eaten
It's
chicken?
delicious fried chicken in
Fried
panko
chicken. It's
of
fried chicken.
deliciousness.
Okay. Have you eaten chicken katsu?
Yes.
All right. Now, Kingston says, I like tonkatsu. What is tonkatsu?
I like shrimp katsu.
What is it?
I like shrimp katsu more. It's not bad,
You
but
like shrimp
I
katsu?
prefer shrimp katsu.
You
more.
like shrimp katsu?
Yeah.
Okay.
I'm not a chicken person.
So chicken katsu is one thing. There's also shrimp katsu,
Yes.
apparently. There's tonkatsu, which is what?
I don't know what that is.
Do you know, by the way?
I like bacon too.
Tonkatsu is
That's
pork.
probably amazing.
What do you think, and this is actually a Japanese word, what do you think bifukatsu is?
Sounds like beef.
Beef katsu, right? Right? It's beef. It's beef katsu, right? All right, so bifukatsu is, right, bacon katsu. That sounds,
That should be a
it
thing.
sounds epic. All right,
I'm gonna
so
make that a thing when I get home.
have you ever eaten, I don't know, let's say that I'm from Texas, and let's pretend that there wasn't any katsu from Texas. I'm like, howdy, y'all. I just moved here from Texas, and I'm going to have a terrible accent today.
So
Please do not shoot me with your gun. Another stereotype. If I'm talking about, like, all right, so what is this katsu stuff? And then you say, well, you take what? You take panko breading and you put it on top of the thing, and then you put inside of some egg, and you put more panko breading on, and you fry it up inside of like some olive oil or whatever, and then you pour it on with some rice and some sauce, and oh man, it's the best, right?
Sure.
That's what you say, right?
Yeah.
Right? And then I'll be like, well, what is it? What is this shrimp katsu, right? And then you can be like, it's the same thing. You just
What's shrimp?
instead of chicken, you use shrimp, and I'd be like, oh, okay. You just eat shrimp and the panko bread, and the sauce, and fry it up, and then serve it and eat it. Awesome, right? All right. And then what is so like? Then I'll ask, but like, you see, in Texas we eat. No, let's say Louisiana, we eat them gators, and you'd be like,
I've had alligator.
and then you'd be like. I'd be like, I want me some gator katsu, Jack.
Dude, that could be delicious.
Hey, Jack, I'd like me some gator katsu.
Excuse me.
Happy,
this would
happy,
be
happy.
Florida, not
All right, anyway.
what? That'd be Florida.
So, you take a
That's
gator,
really good.
right, and you cut it up,
Yeah.
and then you put it in the panko bread,
Yes.
and you fry it up, and all of that kind of stuff, right. Okay, good. All right. So my question to
I really
you...
want alligator katsu.
My question to you is, we talked about all of these different kinds of katsus. Chicken katsu, fish katsu, beef katsu, shrimp katsu, lizard katsu, rat katsu, escargot katsu, which would probably be snail. You could probably even do human hand katsu.
Obviously, escargot
if you wanted.
is That's what escargot means.
The gator katsu,
Yeah.
mongoose katsu if you really wanted. I mean, if you really needed to. Like, you could do parakeet katsu, beetle katsu, I don't care. Hey, I don't discriminate. But what my question is, if you go cat katsu, yes, definitely.
No.
Yes.
No.
Dog katsu.
No. No to all of you.
You know what I am, right? Dog katsu. All right. Anyway,
I'm so racist. Oh my god.
well, I didn't say anything about racist. I didn't say actually. No. All right.
Don't hurt the kitties.
By the way, if any administrators are watching this video now, I'm sorry. Just let you know. Okay, so my question to you is, can I go into a restaurant that cooks all these different kinds of katsus and say, give me some katsu?
Yeah.
What are they going to do?
Yeah, what kind?
Ah, there we go. So, wait, I can't just go in and order katsu.
Why not? They have all stuff for it.
No, but I mean, exactly. They have all the stuff. They make all these different kinds of katsu that we just described, except maybe human hand katsu, because I think that would be illegal in some states. But I'm just saying,
In some states.
would they? Yeah, they have bacon. Of course, they're a restaurant. They have bacon. But would I be able to go into a restaurant and say, "Give me katsu"?
Depends. Are you going to L&L or are you going to, like, I don't know, Gordon Biersch?
No,
Makes a
I'm
difference.
saying there's a restaurant that serves all these different kinds of katsus. Can I say, "Give me katsu"?
Well, yeah, but then they'll
I
probably
want
ask
to
you
eat
what
katsu.
kind.
No, you guys are all saying no. So when I asked you that question at the beginning, have you ever eaten katsu? Have you? Have you ever eaten katsu? Itself, katsu. You've had chicken katsu. You've had
Oh, I feel you.
Pork
yes,
katsu.
I have. I actually have.
turk
It's
katsu.
called just frying bread in panko, like a cracker.
That's not katsu.
Eating it
That's
like delicious. Yeah, that's a katsu.
that's like a potato chip. That's not katsu.
But it's the katsu part. That is the actual katsu part of chicken katsu.
No. I like it. It's a style. It's a style. Katsu is like a style. It's kind of like, it's a way of preparing food, right? It's not really a food that you actually eat. It's a way to
Yeah, it is.
it's a way to take raw meat or raw edible things and turn it into the most amazing fried edible thing.
We went from algebra
That you
class to home ec class.
Stay with me here. This is what a function is. A function has an input and it has an output. It's like a machine.
Best story ever.
And this is my katsu machine. And the input for this thing is meat.
Sponge.
I mean, it doesn't even need to be meats. It could actually be like vegetables. I mean, if you're a vegan,
Yeah.
you could still have katsu, right?
Gross vegetables.
Right, but I mean, so let's say food. We're going to go with raw. Raw food. You probably want to do
Yeah.
raw food at the beginning. And you put it through the katsu machine, which is this style of cooking, and you end up with katsu food. So like if you input chicken, you would output chicken katsu. If you input flan, okay, that's a dessert, but that's cool. If you input flan, you would end up with a mess and flan katsu. If you input alligator, you would end up with, you would output
something
what?
delicious.
Alligator katsu. That's what a function is. A function is a relationship. It's relating one letter or one thing to another. We're defining this function right here. This is f of x. This is saying our function, as it depends on x, is equal to x squared. That's the machine, okay? And what I'm doing here is I'm doing different inputs, which are the x numbers. I'm saying, what if I put in -2 into this machine? And then the machine processes it and says, okay, -2, my command says to square whatever comes in. So if you put in -2, I'm going to square it. And then, oh, hey, that output is going to be 4. You guys understand? This is what a function is. It's a relationship. That's why it says f of x. It's saying this function depends on x. Does that make sense? Okay, good. Now, I have another question for you. Ready? Here's what domain and range is. I have a perfect way of explaining it. Okay. I open up a store. Me and Brandy are going to open up a store. I'm the cook. She's the person at the front desk, right?
Fine.
And you'll be the waiter and the maitre d', and I'll let you be co-owner then. Fine. And I'll cook, right? And I cook the most amazing katsu you've ever had. So we have a weird restaurant where you come in and you bring in raw whatever you want to her. And she's going to say, okay, this person wants chicken katsu. And then you pay me $20 and give me the raw meat. And I'll take that raw meat, I'll cut it up.
Dude, did you know that in New York, there's a place that you bring in your own food and they'll fry it for you?
Yeah, well, that's the same. That's the same idea, right? So
you can fry.
I know,
fried things.
Isn't that amazing that we?
Fried donuts.
Hey, let me finish. All right, so they're going to bring in raw chicken to you, and you're going to give me the raw chicken, and be like, chicken order up, and I'll cut it up, and I'll make the most, and I'll give it back to her, and then so she's going to output the most amazing chicken katsu you've ever had, right?
Speak highly of yourself.
No, it is. It's the most amazing. I'm just saying, letting you know. I'm an amazing cook with chicken katsu. I got the chicken katsu. Now, there's some rules on our restaurant door, and the rules are, you can't bring in a mouse.
Non-edible things.
I mean, you can literally bring in a mouse if you wanted to. And that's fine. If you wanted to bring in a rat or a mouse or whatever, you can bring in a mouse, and I can make mouse cuts on it. But you can't bring in this, a computer mouse. Because I'm not going to cut up the computer mouse. You can't bring in, what else can you not bring in?
Anything that's not, I don't know, edible?
Like what?
Like a lamp?
Lamp. I cannot make lamp katsu. An iPhone. I choose not to cut up iPhones. Okay, a door. Good.
The doors.
A race car engine. Right? I don't cut those up and make katsu. It's going to mess up my deep fryer. Alright. So, so there's a rules of what you're allowed to bring into my house. This is my restaurant. It's my house. In fact, I'm that kind of guy say I'm the king of my domain. I know that you're co-owner, but this is my domain. My domain. Have you ever heard anybody say that? I'm the king of my domain.
Usually, well, yeah, but usually they just say house.
Right. So I mean, right.
But
And what does domain mean? It means my house, my area, right? And if you're in my house, like my daughter, who's 4, nicely. I mean, I'm glad. But one day she might bring home a boyfriend, and I'll be like, I get to set the rules of who gets to come into my domicile, my domain.
Shotgun quietly.
Right? And I'll be like, I'm gonna clean my samurai sword, right? I'm gonna sharpen it, cut like sausages while I'm talking to him. But what I'm saying is, like, I'm allowed to like, this is my domicile. You want to come into my domicile and take out my daughter? Right? Right. So, like a Japanese store. That's a good one. So, what I'm saying is, I get to have rules as to what gets to come in. Right? That's what domain means. A domain is rules on what is allowed to come into your function. Does that make sense? Does that now make sense to you? What is domain?
Sounds like those people are here and they're taking pictures of it.
No, but I mean, you're asking me, I don't understand what domain is. I'm trying to explain it to you. I think I gave you a pretty good explanation. Like, a domain isn't this thing that you said that it was, you said that it was this thing that and then I can't really explain it. You can't really explain it. No, a domain is just the input. If a function is a machine, it has both an input and an output. The stuff you put in is the domain. Does that make sense? Is that hard? I mean, you get it? All right. The stuff that comes out of that machine is what? If domain is the stuff that goes in, starts with an R. There we go, it's the range. The range of the stuff is the output. Doesn't that make sense?
Yes, after you.
And here's the kicker. I mean, like, check this out. It never really became important to you, but now if I'm looking at my function, right? Is there any restrictions on the domain? Look at the problem. Is there any restrictions on the domain? No. I can put in any number I want. Agreed? Is there any restrictions on the range?
Yes.
Yes, why?
Because it comes out with something. It has to come out with something that makes sense to be domain.
Well, no, I mean, no matter what you put in. Oh, there we go. Thomas got it. no matter what you put in, it has to be bigger than 0 with this particular function. There's a domain and there's a range. The range is actually different. It's not the same as the domain. The range says, I cannot, obviously, this graph will never get below 0. There's my range. It's the output. So I hope that this makes a lot more sense to you. I'm sorry, I'm still kind of sick. Anyway, let's do this one. Let's try 2x squared. So let's do this. Let's plug in -2 into here. The input is -2 into the thing, so that's what? 4, but then you multiply that number by 2 and you end up getting 8. Everyone agree? Did I confuse you or what? Okay. I'm going to plug in -1 now, and so I plug in -1, I get +1, but I multiply that by 2, I'm going to get 2. I'm going to plug in 0, it's going to be 0. 2 times 0 is just 0. This one's going to be 2, and that one's going to be 8. Just letting you know. You can check it if you want. If I were to graph this, it would be -2, 8. That means I go backwards 2, left 2, and then up 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8. That would be up here. -1, 2 would be over here. 0, 0 would be here, there, and there. So then I graph that, and I end up getting this. All right, so putting a 2 in front of the x squared did what? Compare that to the regular parabola. What did it do? Come on, folks. It made it thinner. It made it. That's the one that's on the Slim Fast plan, right? So I'm going to say who guessed it. Ted. Ted said he thought it would go wider. But in fact, it actually went skinnier. And I would say, yes, Ted, you're wrong. But don't feel bad. In fact, let's applaud Ted. Ted did an awesome thing because he guessed. And you know what? He actually got close. Sure, he did the opposite of what it actually did. But, I mean, yeah, I mean, at least he didn't say, well, it would go diagonally and then go up and then this way. Obviously, right? Ted figured it out, but he just kind of figured it. He did the exact opposite, right? Gold star for Ted. All right. So apparently, when you put a 2 in front, it makes it skinnier. By the way, I'm wondering, what do you think 3x squared is going to look like? What do you think 3x squared is going to look like? If 2x squared made it skinnier, what do you think 3x squared is going to do?
Make it even
Skinnier than that. What do you think 500x squared? I'm just curious.
Well, damn, that'd be like a straight line.
It would almost go so skinny that it's a straight line. But that's fine. All right, fine. But you guys understand what's kind of going on here. All right, good.
I said almost. Okay.
Let's graph this. How's about this? If I plug in a -2 into here, that would be 4, but then you times that by 1/2 and you end up getting 2. Do you understand? Like, fill out the rest of the table. This would be 1/2, this would be 0, this would be 1/2, this would be 0. Or, I'm sorry, 2. Alright. So if I were to graph that, it would look like this. Go backwards 2, up 2. Go backwards 1, go up 1/2. Go to 0, 0. Go forward 1, go up 1/2. And go forward 2, up 2. So my graph would kind of look like this. Do you guys see that? So it gets wider. Okay. So what if I had, instead of having 1/2, what if I had 1/4? I'm just curious to know.
It would make it even wider.
Even wider. Good. You guys understand what's going on here?
No, wider.
So if I have my, like, I don't know, f of x is equal to 1/6 x squared, whatever, 1/6 x squared, what would that graph be? What do you think that would be? So the smaller, the wider, and the larger, the thinner. Yeah, exactly, Ted. The smaller the coefficient is in front of the x squared is, the wider that thing is going to get. And the higher that number is, the skinnier that thing is going to get. I love how Ted came up with that.
The Irish wristwatch.
No, I'm not going to say Irish wristwatch. Wait, no. You got me to say it. All right. Anyway,
Fail.
let's try this one. Ready? I love everyone write down what Ted said, because let's make that a rule. And I'm going to have to clarify what Ted said, because what you're saying is the smaller the coefficient, the wider the parabola. Is that what you're saying? That's what you mean, right? And by coefficient, I mean the number in front of the x squared. Good. We're doing math by Ted. I know what you said, Ted. I'm not going to get you. You're not going to get me to say that.
Again, because you already did.
All right, ready? All right, good. I'm glad you guys wrote that down. All right, let's try this one. Let's plug in -2 into the x squared. So that would be -2 squared, which is +4, but then you plug a negative in front of that, it would be -4. This would be -1, this would be 0, -1, and -4. Let's actually try to graph that, and if I were to graph that, it would go like this. By the way, this is very much like what you're going to have to do in your homework, so pay attention. So, compare that to the regular graph. What does the negative in front of your x squared do? What does it do? It opened up positive before, but now what does it do?
No, because it's a negative.
It opens up, it flips the parabola. It flips it upside down.
Every time I see the word parabola, I think
Now-
it's Pandora.
Now keep in mind that what you mean by flip is it doesn't turn it this way. It turns it that way.
Flips
Like it flips it.
horizontally.
Yeah, I don't know how to describe flips.
Horizontally. It's horizontally.
Yeah. I don't know if this is, I don't know, whatever. It flips it this way.
Horizontally. Over the x-axis.
Alright. It flips it around the x-axis. That's a good one. Alright, let's try this one.
Yes, technically flop would be the term for going down.
I'll tell
Like
you.
it's this
I'll
way.
tell you what. Let's not even graph it. Let's guess what we think the graph is going to be. Graph this one. What do you think is going to happen? -2 x squared. Upside down, but thinner. I totally agree with you. I think it's going to look something like this. Probably around here and here. It's going to be like this. Well, let's plug it in and let's see. If we plug in a -2 into here, that would be a 4 times -2, which would be -8. This plugged into here, that would give me a +1 times -2, which is -2, 0, -2, -8. So if I were to graph that, I would go backwards 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I graphed it perfectly. Without even doing a table, you graphed it. Dude, that's cool. Oh, come on. Don't be all like,
Sorry, I'm just really tired.
don't be like that though. I mean, come on. This is kind of cool. And I didn't even graph that. That was actually John who said it. John said upside down and thinner. Okay, that's cool. That's cool.
Jonathan gets extra credit.
All right, let's try this one. -1/2 x squared. What's going to happen? Perfect. Finish him. Fatality. Flawless victory. KO.
That's pretty good.
Yeah, I know. Alright. Upside down and wider. I totally agree. So here's a regular parabola. A wider one is going to look kind of like this. And it's going to be upside down because it's a negative in front. Are we cool?
Uh-huh.
Alright, good. So I'll let you answer these questions. This is not actually a part of your homework. Well, I'll tell you what, why don't we talk about it? And then, I don't know how much of a break we can take, but anyway, all right. How does a graph of a parent function change when a is negative? If a, and what I mean by that is the general function that we have is f of x equals ax squared. Let's stick with that for now. Ax squared. So if a is a negative number, what happens to it? It's going to make it upside down. Good. It's going to flip it like the Filipino that's teaching you. That was offensive, I think.
It was great offensive, though. It was like on the good side.
I'm like on a roll today. I don't know what's going on. Anyway, the sickness is getting in my head. All right. How does a graph of a parent function change? By the way, I am Filipino, just in case you didn't know.
Yeah, that's the point why it's not offensive. Because you can
How does a graph of a parent function change when the magnitude a is greater than 1? Does that make sense to you?
No. Can you repeat yourself, please?
If this number were 2, how would that graph change?
It would be wider. Right? I don't know.
She says it's wider.
I didn't say anything. Liar.
She said it privately.
Liar.
If that number were 2, it would make it thinner. It would be narrower. It's on the slim fast plan, remember? Yes. If it's bigger than 1, then it would be skinnier or thinner or narrower, however you want to call it. I don't care. All right. What if how would it change if a is smaller than 1? And by smaller than 1, I mean like
Then it would be wider.
Then it would be wider. Exactly. There we go. How do you think the graph of 3x squared would differ from 2x squared? 3x squared would be a little bit thinner. I totally agree. There we go. How do you think the graph of 1/3 x squared will differ from 1/2 x squared?
1/3 x squared will be wider than
1/3 x squared is the fatter one. Ha!
God, fat's such a derogatory term. Bigger. Fluffy.
Alright. Let's look at this now. Do you guys need a break?
Yes, please.
I feel like you need a break. I'll tell you what, I'll give you a 5-minute break if you let me go all the way to 11 o'clock to teach you. Which is why.
You're welcome.
I
Oh,
finished
did you
last
yawn
night.
too? Ha! I made it happen.
Alright. 5-minute break.
I like Jonathan's idea.
7-minute break.
What am I doing?
Alright, I'll tell you what, I'll make a deal with you. I'll give you a 7-minute break, but I get to go fast when I come back.
Fine.
Deal?
Fine.
Alright, 7-minute break. We're going to start at 7 minutes from now. Sorry, I came back. Bam! That just happened. I'm sorry, I forgot to, I like started lecturing for like 5 minutes and I forgot to record. But anyway, what happened was we plugged in x squared plus 3, all snap, and it ended up being the exact same thing as our guess. I like that. Alright, cool. Let's try graphing this one. If I'm going to plug in -2 into here, by the way, this function is now called what? H of x. Okay, fine. It's not an f of x, it's not a g of x, it's an h of x. That's fine by me, you know? You call it whatever you want. I just know that it's a function. So h of x is equal to x squared minus 1. By the way, this is not h times x. You guys understand that, right? That's not h times x. That's saying h of x. Because remember, I'm telling you guys that a function isn't like a regular thing. A function isn't a food. Or katsu is not a food, right? You guys remember that. Katsu is not a food. Just like a function is not a number. You don't multiply the number times, you know what I mean? You don't multiply the function times x. This is saying that this function depends on x. That's what this is saying right here. Cool? Alright. So, if I plug in x squared, or -2 into the x squared, that would be positive 4, but then I subtract 1 off of that and I get 3. You guys agree? Alright. Do the next one for me. Thomas is saying 0. Okay, what else? -1, there we go. And I've noticed a pattern. Can I just put 0, 3 already? I noticed that the numbers on this side are the same as the numbers on this side. You guys see that? I'm just wondering if you noticed that.
Yes.
Anyway, let's graph this thing. That means I go backwards 2, up only 3. And I go backwards 1, down 1 this time. And I'm going to go, no, I mean, not down anything. I'm going to go backwards 1, 0. And I'm going to go 0, -1, and then this one, and then this one. So my graph looks kind of like that. By the way, what is the range of this graph? What is the range? And what I'm saying about the range is, what are the y values allowed to be? And Thomas, it's actually opposite of what you're describing. It's, oh, okay, I think I get what Bernice is saying. It's basically, Bernice is saying, as long as it's bigger than -1, right? The y value, the height that it can go to, the lowest it goes to is -1. So as long as your range is all the numbers that are bigger than -1. Does that make sense?
Mm-hmm.
Yes, because that's the smallest number in the y version, in the y column. The x has any real number. You can choose all the numbers you want for, what you can put in, what it's allowed to be. But the y values only have numbers that are bigger than -1 being what it's allowed to be. So your domain is all real numbers, whereas your range is any number bigger than the 1, or -1. We cool? All right. How does the C reflect the graph? What I mean by that is, compare this to this function. F of x equals ax squared plus c. Do you guys understand? We understand how a affects it, right? We talked about that for like an hour. If a is positive, it goes up. If a is negative, it goes down. If a is a big number, it gets skinny. If a is a fraction, then it gets fatter, a wider one. How does c affect it? If c is positive, what happens to the graph? Think about it. You make up the rules. This class is about you making up the rules. It goes down. No, it actually goes up. If c is a positive number, that means you push that thing. Because remember, if c were positive 3, that means you move that thing up 3. If c is a -1, that means you move that thing -1. John, you're my all-star today. Bernice, I'm glad you threw that out there. And it actually ended up being just the opposite of what you said, which is not a bad thing. Because you guessed, you threw it out there. So, can you guys write that down somewhere? If c is positive, then graph moves up. And then I'm going to put ditto, c is negative, then graph moves down. Have you guys seen ditto before?
Yes.
This means, whatever, blah, 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 right there. So I'm lazy, I'm just going to write it down. You guys can write it down. If c is positive, then the graph moves up. If c is ditto, 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 negative, ditto, 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 down. Got it. Now I'm going to move on. You're just going to be like, I didn't finish copying it down. Well, make up your own rule then. All right. I want you to notice the parent function only intersects the x and y axis at the origins. But when the c, oh, okay, all right, yeah. So what they're saying here is, you notice how on the other graphs, the one we were doing before these ones, all of the graphs intersected right there, at that point right there, right? Even if it got thinner, it still crossed right at that origin. That's what we call the 0, 0. Even if it got wider, it did that. But for the graphs where we messed with the C, and that moves the whole parabola up or down, that changed where our intercepts were. But it also changed where our vertex was, right? Cool? So what is our, if I have x squared plus 3, what is our y-intercept? And I think Kingston kind of pointed this out. So Kingston, go forward and throw it out there, and if you don't answer. What is our y-intercept? Where's this graph going to cross the y-axis? This one right here. At 3. Awesome. And where's the x-intercept of this graph? Where does this thing cross the x-axis? It doesn't. So we can put D and S. Or D and E. Does not exist.
That would be like NA.
NA, not applicable? That's fine too. Just be like, that's dumb, Mr. Dalday. Don't try to trick me. Because I'll take that too. You guys write that and just be like, that's dumb, Mr. Dalton. Don't try to trick me. I know better than you. Well, actually, you probably don't know better than me, but I don't fall for your tricks. I'm like, all right, fine.
Got weird wannabe French in the middle of that laugh.
Yeah, so C is like the B in slope-intercept. Yeah. I know, it seems kind of funny. Would you guys like to know why we call it C? Why is it ax squared plus C?
Sure.
Is because the actual function that we're talking about is this. Ax squared plus bx plus c.
Yeah.
We haven't discussed what b does to it, but we understand what a does to it, and we understand what c does to it. When you add in that b, then things get really funny, and that's what we haven't talked about yet. And this is the most general kind of parabola we have. So this is f of x equals ax squared plus bx plus c. John is guessing that the b moves it to the right and the left. And John is absolutely almost correct. It's a little bit.
It's really one of the things that I hate is when you're like code wrong, because then your hopes get up for those 3 seconds and you're like, God.
It's
no.
almost. I mean, Kingston's saying that it moves it up and down, and that's actually wrong too. Actually, it's almost. It's like a wrongette, because it's actually more correct than it is wrong. So anyway, this one is a funky one, and I'm not going to cover that today, but I'm just letting you know. All right, check this out. Let's do this one. H of x equals x squared minus 1. What is the y-intercept? -1. No, don't get confused now, John, because you've been hitting it. You've been doing awesome. So just kind of hang out and say, all right, fine, I'm going to accept what you have so far, and then let's, we'll take it as it comes, because I'm going to ease you into this. All right, what is the x-intercept of this graph? Think about this one. Of this graph right here, where does the graph cross the x-axis? If you need to graph it, graph it. By the way, this is not the graph. What is x-intercepts? Kingston says 1. So you're telling me that this graph is going to cross the x-axis at 1? Jonathan's got it, and Kingston's got it, and Thomas has got it. Essentially, what it is if I were to graph this parabola, where does it cross the y-axis, or the x-axis? Yes, it's going to cross at a positive and negative point. That positive and negative point happens to be positive 1 and negative 1. Does that make sense? So this thing has 2 x-intercepts, but only 1 y-intercept. Awesome, awesome. All right. Let's try this. They want us to graph 2x squared minus 3. I'm just going to ask you, how would you graph that? What would you tell me what you would do, and I'll do it for you. Two x squared minus 3. What would happen? What does a 2 do? What does that 2 in front of the x squared do? It will be upside down on the negative 3. It makes it thinner. Okay, John's saying that it makes it thinner. John's also saying that it makes it upside down, and I disagree with you there. That's like the only time you got something wrong today. Besides saying that it goes right and left and everything. I didn't count that. The negative 3 makes it upside down. No, it doesn't. The negative 3 does not make it go upside down. Look at the graph. 2x squared minus 3. What is the 2x? There we go. Bernice has got it. It moves it down. John, if this were a negative 2x squared, then it would be flipped over. I agree with you. But it's not a negative 2x squared. It's a positive 2, so we know that what does the 2 do? It makes it skinnier, right? Now what does the minus 3 tacked onto the end? That takes the graph and it moves the whole dang thing down 3 units. So my graph will probably look something like this. Do you guys agree? It will be skinnier than a regular parabola, and it will be moved down 3 units. You like that? All right, let's try this one, because these are fun. I find them fun. Negative x squared plus 2. What does that graph look like? You tell me what you would do. You can even sketch it. And you're the only one who could show me, but I mean, sketch it. I want to see what your thoughts are. Flopped over and move it up 2. I agree. So it's going to be a regular looking parabola. You're going to flip him over and you're going to move him up 2. So it's like 1, 2 right here. Is that what you guys got? Yes. You guys are so good at this. 3x squared minus 4. What is that going to look like? Tell me. 3x squared minus 4. It's going to move down 4, and it's going to be super thin. 1, 2, 3, 4, super thin. All right, I'll tell you what. Check this out. I have a graphing program. 3x squared minus 4. Let's get rid of this keyboard. The red one is your regular parabola. The blue one is your 3x squared minus 4. It's down 4. See? Negative 4. And it's skinny. And by the way, if you guys... It's
good cheating.
Hey, that's cheating. And you guys are like, hey, Desmos is now in my notes. All right, fine.
Yes.
You want to use a graphing calculator on your in your homework? Okay. I'm not going to stop you.
/calculator.
All right. But I think that what I have you guys doing is I have you guys like actually plugging in the equations to me. What you have to do is you have to show me your work. You know what I mean?
Oh, crap.
And since you have to show me your work, sometimes having a calculator doesn't always help. But you can use a calculator to check your work. I do that all the time. All right, enough of these tables. Let's just graph it. Let's graph it like I was gonna say men, but we're not all men. Except Raimana.
Oh.
Raimana is a
my
man.
God, you can say like men because women are just as capable of doing things as men are. It is not rude to say like men. The feminist in me will slap someone because it is not. It is a thing. It's fine.
Do you know who Rosie Riveter is?
Yes.
Okay, I'm just do you know who? Gosh. See, I actually took women's studies in college. I studied the feminist movement.
Points to you, Mr. Golding.
Ha! Ha! You thought I was
Yeah.
a feminist, but I'm not really. I mean, I'm not really. I mean, I'm like a chauvinist, but I'm not. I took women's studies. I understand about the
Dude,
feminist
it's probably
movement.
like a great class. I want to take that class.
Yeah, it was great.
But I don't need that class. Alright, no.
Yeah. Yeah, I know. I know. I'm sorry, Ramona. No, it wasn't that I thought you were a girl. It's that I had a student for a very long time that's named Rayana. And you know, she was a girl. So I'm just kind of, yeah.
My mom knows to be a feminist when
All
she
right,
named
anyway.
me Brandon.
1/3 x squared. How would you graph that? Graph it. What would you do? Come on. I love this game we're playing. We got 10 more minutes. Let's do it. You don't like it?
I don't like this game.
Really? Not that bad. 1/3 x squared. It's going to be... No. I don't want a Jeopardy music play. I want to just graph it. I want to finish these 4 problems, and then I want to end class, and then, you know, let you guys go home. It's a fat graph. Yes, exactly. It's like a parabola. It's just going to be a little bit more, you know, like, hey, he's heavier. All right? That's true. Technically, you are home. But I want you to, like, let you go back to playing, you know, whatever it is you play. Or doing homework. All right. H of x, let's do number 2. Negative x squared plus 4, what would you do? Negative x squared plus 4. Pop quiz, folks. Upside down and up 4. Exactly. Something like that. Agreed? All right. Now this tells us to we're going to do something different. We're going to say instead of just reading off the thing, we're going to follow what it says to do. All right, fine. It says stretched by a factor of 2 and shifted up 1. What does that mean? Stretched by a factor of 2.
I don't know, microwire, stretch it.
By stretching it, you mean, remember, if it's a number bigger than 1, we stretch it this way. If it's a number like 1/2, that means we pull it this way. So stretching by a factor of 2, yeah, Bernice, that's exactly it. 2x squared plus 1. Yep. Something like that. So mx equals 2x squared plus 1. Perfect. All right. Reflected across the x-axis and shifted down. How would that equation look? You want to take your parabola, reflect it across the x-axis, and shift it down 3 things. Negative x squared minus 3. That's exactly right, Jonathan. It's just the negative flips it down, the minus 3 pushes it down. And that's it. Boom shaka. Aw snap. We're done. Booyah. Flawless victory. KO. Ready, guys? I'm out.